Alright, time for some fun. Let's dive into the bounding curve token. So I'm going to go over this file like line by line so that I can explain kind of everything that's going on. And it could also function as a crash course into Solidity, though I would recommend like taking a proper crash course into Solidity first. So I started the file off with this SPDX license identifier. This is how contract licenses are usually noted in Solidity files, and there are actually some tools that can go over a Solidity file and say, okay, you're actually, for example, using GPL code in this contract by going over the imports and so on. And the idea is that this is machine readable. Moving on. The first line of code is this Pragma Solidity. This tells the compiler, okay, I want Solidity support for this version of the compiler, and actually if you try to run this on another compiler, it would error out, because there are some features we use from Solidity 0.8. Then we import a number of files. We use ERC20, the interface. Then we use the safe ERC20 utility, which is a library. It's like extension methods in C#. So the first argument is like the ERC20. And the idea of using safe ERC20 is that ERC20 can actually return false from the transfer function, which would trigger a revert, and safe ERC20 just wraps this behavior into a library. Then we have this ERC1363 Spender interface for approve and call support. Just a reminder, this is the interface with on approval received. So this should get called from on approve and call on the target contract. And finally, we use this owned contract from the voting folder, which is a bit weird, and I would admit to some spaghetti code here. This should probably get moved. But the owned contract is a pretty simple contract, which has an owner, which gets set into constructor, and can then be replaced by calling setOwner. However, setOwner can only be called by the owner, and we do that by adding this modifier, which requires that the sender of the message, so the caller of this function, is actually the owner. And for example, this could be useful to transfer ownership. So for example, the bonding curve is created with one beneficiary, so the beneficiary is the owner, but then the beneficiary wants to transfer ownership and like give the bonding curve funds to another address. So moving on, we have the bonding curve contract, and it extends the ERC1363 Spender interface and this owned. Solidity supports multiple inheritance, but we don't use it here, so we're good. And then we say we are using this library, so this library of extension methods for ERC20, which is like the type. And we will see that we can later, for example, down here, we can use safe transfer, like if it was a method on ERC20, while it actually comes from the library. Then we have a number of events. We emit the buy event when somebody buys from the bonding curve, and the sell event when somebody sells to the bonding curve, with amounts in both of the tokens. And we also have some events related to the so-called transition. And I think I will actually want to explain a bit more about how the bonding curve is supposed to function first. So the idea is that we have an amount of tokens that we're trying to sell. So this is token A. And we also have some amount of tokens which we have received from people. This is token B. So like when a person comes to buy tokens, they give us token B and we give them token A. So over time, token B grows and token A shortens. And selling is actually the same thing in reverse. So when somebody comes to sell, they actually give us token A and we give them token B. Trolio is misbehaving. Okay, there we go. And the idea behind the transition is that when token A is almost finished, we start the so-called transition, and token A goes to 0. So when we have sold all our token, then the beneficiary, I think, can trigger a transition, which will transfer all of the token B that has been collected to the owner or beneficiary. So actually, after the transition, the bonding curve stops being a bonding curve because it runs out of funds. And the idea is that the owner should be the voting, or the voting that is formed by the holders of token A. That way, after the transition, the control of the token that was like raised as funds then belongs to the people that bought it. Anyway, back to the code. Those events are there just to have a way to warn users of the fact that there is a transition pending, because it is one of the more important events in the life of the bonding curve. Then we have token A, token B. Here we are using those immutable type variables. That's actually the storage of the variable. The idea is that we can set those only in the constructor, and afterwards they are immutable. And it helps to save some gas usage actually, because otherwise we have to store them in the state of the contract, and state usage is very pricey. So we have token A and token B. Then we have a variable that tells us the total amount of A tokens, the initial price, the initial price is when the balance of token A is equal to the total balance. And when the amount of token A goes to 0, we go to final price. Actually, when it is 1, then the last one goes to final price of token B. And we also have this price divisor, just in case we need to make some fractional prices. Then we have this so-called tax, which is like a fraction of B tokens that are given to the bonding curve that become immediately available to the beneficiary. And those funds cannot be like refunded if you sell back. So just to like go back to the diagram, when somebody buys, actually a bit of the token B they deposit is this tax. And if somebody buys and then sells, they will leave the deposit of tax in the contract. And then we have the transition balance A, which is when the transition starts, and the transition happens when the price has like the balance of token A has stayed below the transition balance for this amount of blocks. And finally we have actual state with this packed command, which is meant to signify that those variables are with carefully chosen sizes so that they will fit in less state cells and use less gas that way. And here we have the transition end block, which is when the transition ends. Then we have the balance A, which we use for later. Let me just check how we use that. All right. So the idea here is that we actually never check the balance we have in token A, or I think token B, and we just go off state variables, which means that actually the bonding curve can run out of funds at any price if it doesn't have funds in the token, which has to be double checked by users. So the users should check that the bonding curve has enough token A tokens to cover for this balance. And finally, we have the withdrawable amount, which is the amount of balance B that the beneficiary can withdraw immediately based on those taxes. So this was the first part so far, the preamble. Then we have the constructor, which takes a number of parameters and the owner, and just sets those things in the state. And that's about all the constructor does. Don't think I have to dive into this. And then we have some functions related to the transition. We have this when active modifier, which just checks that we have not transitioned yet, and we use the transition end block variable to mark the end of the contract, and if it's set to the max value of whatever type of variable it is, then we count that the transition is now finished. Then we have this enact transition function, which should happen when active, and we just check that we don't have any balance A left to sell and that the block number is over the transition end. And in this case, we mark the contract as inactive, and we give all the token B that we have accumulated to the owner. And we emit that the transition has ended. And after this function runs to the end, then the contract becomes like just a dummy contract. There is also this private update transition function, which just checks if the balance A that we now have is more than the transition balance, and if in this case we cancel the transition, and otherwise if it's less or equal to the transition balance, we start the transition. And now we again reuse the transition end block variable. So like when it's 0, we know that a transition is not yet started. And then we have the buy and sell functions, which are going to be a bit of a chore. But for buying, the buyer says, okay, I want to buy amount A of tokens. I'm willing to pay up to amount B of tokens. And this is the recipient address. So I can like buy tokens for another address. This is just to ensure that the contract is as multifunctional as possible. And we actually have the implementation in another function so that we can use it later on with ERC1363. And here we have some utilities. For example, if the recipient is the 0 address, we assume that the recipient is the sender. And if the person requests more A tokens than we have in the bounding curve, then we just give them all the tokens we have. We calculate the final balance A we have. So after this buy concludes, we are going to end up with this amount of balance A, of A tokens. So maybe just to go to the... So this is like balance A, and this is end balance A. Then we calculate the amount of B tokens that are needed. And we do that by calculating, we use this function which functions a bit like an indefinite integral. So this is all the amount B we are expecting to receive for this amount of balance A left. So, come on, sorry. So basically, not counting taxes, we expect that by selling this, we're going to receive this amount of token B. Then we see that by selling this end balance, we're going to get some smaller amount of token B. And it really is like an indefinite integral. So we take the difference of those two values, and this is the amount of token B that we expect to receive in this buy transaction. We then check if the amount without the tax is less than the max amount of token B that the user is giving, and we report an error in this case if it's more. Then we take the amount of tax from this. We mark it as withdrawable, and we mark it as withdrawable. Then we update balance A and like update the transition. So if we need to like start the transition or cancel it, then we actually transfer from token A to token B. We could do this earlier, but the general practice in Ethereum is to first update your own state, then call any other tokens. That way we don't have reentrancy bugs, because otherwise, for example, this token could call back to us in some way. That's actually how some hacks have happened in the past. So it is important to keep calls to external contracts as far as possible from the start. And finally, we emit a buy. So just to go back a bit. So when we do safe transfer from or safe transfer, uh, actually the token is responsible for checking that that these funds are available. So when we get here, we just say, okay, we want this amount of token from the sender to be transferred to us, and if the sender has not approved such a transaction, or if the sender does not have such funds, this will just error out, which is great, and we don't have to double check such things. And likewise for token A, just transfer them to funds and assume that we have them in storage, like in the token. And if we don't have those funds, well, too bad. Somebody should transfer some A tokens to the bonding curve, please. Then we get to the sell function, which is pretty much the same thing, except that we're now setting some amount of token A tokens for a minimum amount of token B tokens. Again, we have a private function implementing it. Again, we have a recipient in case somebody wants to sell their tokens and receive the funds on another address. We check that the user is not selling over the total balance of A, because when we reach the total A balance, which is like the maximum amount of A tokens that we can have, then they're going to be selling for 0. We calculate that amount of A tokens. Again, we calculate the difference in B balance, and here we calculate the taxed amount. So it's just like here, we calculate the amount of tax. However, this time the actual amount of B tokens we're going to transfer is the pre-tax minus the tax. So in a sense, this is our pre-tax amount, and a bit of that pre-tax amount is actually the tax. So when the user is wait, why does it write sell here? Anyway, this is a very messy graphic to do. Anyway, the idea is that when we buy, then the balance A goes down. When buying, balance A grows smaller, and when we sell, actually the balance of A tokens grows larger. However, since we never record the actual amount of balance B, so of B tokens that we have collected, that's why we calculate the tax when selling and just give this amount B to the user, since we have already committed this tax to be given to the beneficiary, and we have to make sure that we are not like giving the same coins to two different addresses. And then we like check that the amount of B tokens is more than the minimum amount that the user requested, which can happen in case of price slippage. So if too many people sell at the same time, somebody is going to get left with less amount B tokens, and maybe they don't want that. Then again, we update the balance A, so how much A tokens we have left to sell. Then we do the transfers again. Actually, the order of those transfers does not matter, but I try to first receive funds from the user and then send the converted funds to the user. Though it doesn't matter, because if either of those two reverse, the whole transaction will revert. And finally, we emit a sell event to let web interfaces and so on know that somebody has sold tokens on the bonding curve. And that's actually the majority of the bonding curve functionality in just the buy and sell functions. And then we just have a few more things. One is the ERC1363 receiver, or actually spender implementation, which is when you call approve and call on an ERC1363 token and approve that you want to use tokens on the bonding curve, then it would receive this on approval request received call, and it just checks which token actually coded. Now it's completely possible that one of those tokens actually does not implement ERC1363, because ERC1363 is very new. However, we do this just in case one of the contracts implements it. And in our case, actually, token A is likely to implement it because it will be our token. And here we decode information such as the amount of A tokens from the B token, and or the amount of B tokens from the A token. And that's about it. And in the end, we just end up calling the private buy or sell function, respectively. And finally, we have to return this on approval received selector, because that's how the ERC1363 token knows that we actually support this function, and not just like catch all do nothing in case we receive an unknown function call. And this is like an implementation detail due to how Ethereum functions. Finally, we have this calculate due balance B function from before. And I should be having the math outlined here, but the basic idea is that we make a formula for the price of a single token based on the final price, the initial price, the balance of A tokens, and the total balance of A tokens. You might notice that we're not having the price divisor here anywhere. This is to simplify the formula. And then we calculate the due balance B. This is a misnomer. Based on summing this price for every balance A value from 1 to the actual balance A. So this is the price of a single token, and here we sum all the single tokens from the first token to the current token, so to speak. And then we expand and simplify and make sure that we have the divisions proper so that we have a higher precision. So the divisions at the end, because this is actually an integer division here. And then we just have this same formula out here. I'm not double checking the math on the call, on the video. You can double check it on your own. And we just make sure that we don't do anything silly. For example, this is a unsigned integer, so going -1 here actually causes a revert. So just double check that nothing breaks. And that's about all the calculate due balance B. And finally, we have the withdraw function, which can be used only by the owner contract or address. And it takes a recipient and an amount to withdraw. And we end up just transferring that recipient that much of the withdrawable amount. I'm making sure to update the withdrawable amount as well. And that's about all for the bonding curve. Let me know if there are any questions after this explanation, and I might be able to explain anything I have missed on the video. Thank you.